it's recording. Camila. Everything okay, Camila? Ok, entonces es logaritmo base 14. You let me know si I did that or no. Of x plus 5 equal 1 minus logaritmo base 14. I suppose que no. Of x. Yes or no? We did that or no? Ah, yes, we did that. Oh, I'm crazy. Oh, no. We did that. Yeah. Next is different. Next is logarithmic of 3 plus x minus logarithmic x minus 3 equal logarithm of 3. It's the next. Yes. Well, something is weird in this problem, no? I do not specification the base here. Why not? What do you suppose que no?
It's the 10 by default.
Exactly, 10 by default. Very well. So now, similar idea, but in this case, we have 3 logarithms. So I propose you, when you have logarithm on the right-hand side, and the left-hand side, not necessary you change to exponential. Why not? Because you condensing this and this in only one is property 6, no? Because of subtraction, the division. So you have logarithm of division 3 plus x in the top, x minus 3 in the bottom, equal logarithm of 3. That's not necessary, because now if you have 2 logarithms and the base is the same, it's because the argument is the same. Makes sense, right? And the rest is easy. You maybe apply cross multiply. 3 plus x times 1 is equal to 3 times x minus 3. Linear equation, distribute the property, 3 plus x is equal to 3x minus 9. 3x stay here, minus x, and 3 plus 9. 3 plus 9 is 12. This is 3 minus 1 is 2x, divided by 2, x equals 6. And this is our potential solution that you need to check in the original equation. Do you follow me?
Yes.
Mandatory checking. I need to prove somehow the logarithm of 3 plus 6 minus logarithm of 6 minus 3 should be equal. I claim this statement. Logarithm of 3. Okay, 3 plus 6 is 9. So logarithm of 9, base 10, of course. Como logarithm minus logarithm base 3, because 6 minus 3 is 3, should be equal logarithm of 3. There are many ways to prove this. You put in a calculator? No. Right hand is better. You condense this again, similar. Is the logarithm of 9 over 3. One more time using the property number 6. Is equal logarithm of 3. It's obvious que yes, because 9 divided by 3 is 3. You get the true statement. Therefore, the solution 6 is perfect. This is our solution set. 6. Any question? No problem. No? Okay. One more, similar. ln x plus ln x plus 2 is equal 4. solve this equation. Solve for x. Okay, nice. In this case, you're condensing this logarithm only one, using the property number 5 because it's plus. Logarithm of multiplication x times x plus 2 inside the argument of the ln. The ln, remember, is a symbolic way to indicate ln is equivalent of log g, but the base e. Equal 4. Okay, entonces in the right hand side we have no logarithmic. Entonces I need to convert to exponential. The base is e. The exponent is 4. Is equal x times x plus 2. And you have a new equation. Okay, this new equation is relatively easy because it looks like quadratic equation. Look, x times x is x squared plus 2x minus e to the 4 equal 0. Okay, entonces, for solving this equation, obviously the only possibility that we have is using the quadratic formula, no? A is 1, B is 2, and C is negative e to the 4 power. It's a number, it's a constant. The formula is minus b plus or minus square root b squared minus 4ac divided by 2a. Is minus 2 plus or minus square root 4. This is 2 squared, no? Minus 4 multiplication by 1 is a multiplication by minus e to the 4 power is positive e to the 4 power divided by 2 times 1. Well. I know that the answer is expressed. It's expressed in like a function of e constant, no? But I can simplification a little bit because I see here that 4 is a common factor. So you factor out 4, 1 plus e to the 4 power divided by 2. And of course, square root 4 is 2. So we have so far minus 2 plus and minus 2 outside the radical. And inside the radical stay 1 plus e to the 4 power divided by 2. And the 2 is split. Negative 2 divided by 2 is negative 1. And 2 divided by 2 is against 1 plus or minus square root 1 plus e to the 4 power. So actually, in this moment, we have two solutions. Okay, negative 1 plus square root 1 plus e to the 4 and negative 1 minus square root 1 plus e to the 4. But it's obvious that this solution doesn't work because this solution is negative. It's negative. Obviously, when you plug in negative inside the logarithm, give me a undefined. However, this is not undefined. Let me see in the calculator. Put in my own calculator is because I want, well, you leave it like that. So you want to express the exact solution, but the approximate answer is minus 1 plus square root 1 plus, I try in my calculator, e to the 4 power. Okay. And the answer is 6 point. Approximately, this is approximately 6.45, 64, no? Because it's 64 one something, 4 decimal place. Okay, the frequently approximation that we are using in the test, 4 decimal place. And you can verify and you can check it. Yeah, you can. Let me try. For example, I put in my calculator natural logarithm of this number, 6.45, 64 plus ln again, 2 plus this is 8.45, 64 should be 4. I claim that. Okay, let me try to say now I want to use my calculator. Is, is natural logarithm of that number plus natural logarithm of that the same number plus 2. And that's it. It's expression. So a substitution that number and the answer should be 4. Excellent. In the calculator you compute that and the answer is 4. 4 equals 4. Fantastic. Okay, and the solution is this solution. Okay, would be fantastic if you try to verify in your own calculator, no? Pero bueno, no now. So I don't know si you have time or not. Okay, so now we study now the applications. So application in the real life. And what part are we using? Bueno, ese sample, no all of them. Logarithmic and exponential functions in finance, in physics and chemistry, biology. Okay. Yeah, basically this. Physics, biology, chemistry, and finance. Let me explain first about the money, cash flow. For example, we deposit money. So compound interest formula. Compound interest formula. Okay. I suppose that you have money. Now. I call P. P represent present value. And you deposit this money in the bank account. And any bank account has interest rate. Interest rate. I want to call R. R represent the interest rate. Actually, some, credit card called APR is the same, annual percent rate. Because it's annually, no monthly, no daily, no, it's annually. And normally it's expressed in percent, annual percent rate. However, in the formulas, we express it not in percentage, we express it in decimal. But it's okay. The important thing in the cash flow analysis, we using cash flow line. Okay, and I need to understand in this line how my money is progressing. Suppose in this moment, for example, in 1 year, this line represents 1 year. Or not necessarily years, it's periodic, one period. But okay, to simplify the thing, suppose que es 1 year. Entonces you have, si you don't withdraw the money, you have that money plus the interest earned. The interest earned is the multiplication RP. Okay, suppose que the interest rate is, I don't know, 0.05. You multiply 0.05 times P and give me the money gets earned in interest. But this is the money in earning interest plus the original money that we have together is because this money, you know, so this is RP. However, we have another branch of money, okay, P, because nobody touched that money, no? So this is expression gets P, capital P, present value, 1 plus R. Okay, this is a money that we have in one period, in 1 year maybe. Suppose another H and another node, this is a node, and another H, suppose another second, and you multiply, you multiply this money, again, multiply by interest rate. So in this moment, you have R times PR, no, we have R, you have R times this money. So it's basically R times P, let me see, braces, RP1 plus R. Plus the other money que you don't touch, que this is P1 plus R, P1 plus R. Oh, entonces hay factorization, P1 plus R, P1 plus R, and we have R plus 1. Okay, 1 plus R and R plus 1 is the same, entonces P1 plus R squared. Entonces it's easy. What's the formula? The formula and this is in the node 1 year, 1 period, it doesn't matter. And the third, not necessary to compute again, is P1 plus R cubic and so on. And the 4, okay, entonces the future value, capital A is called a future value is present value multiplication by 1 plus R, and T represent the time in year. Oh no, let's refine the formula. I want to generalize, not necessarily year, monthly, maybe annually, semi-annually, quarterly, daily. Okay, now this is the compounding part. Compounding es el parámetro que indica us the typical period and the cash flow. For example, when the n is equal 1, que es the thing we are doing now, 1 year, 2 year, 3 year, is annually. Nice. When the n is 2, it's like you imagine 1 years, but you separate in two periods, 2 equal periods. So 6 months and 6 months. This is called a semi-annual. Annually, MM. Okay. And n equal 4 is you split the years in 4 periods. And this period is called quarterly. Quarterly. Okay, this is different kind of account, guys. Semi-annually, annually, quarterly, monthly, bueno, monthly is 12 because 1 year has 12 months. And final weekly is 52 because 1 year have 52 weekly. Or daily, que es 265. Entonces si yo introduce the compounding in the formula, let me explain the modification of the formula. The future value now, using the idea for the compounding, is present value 1 plus but the interest rate R, by definition, is annually. Pero si es semi-annually, quarterly, you divide the interest rate divided by M. Because you want to earn R in 1 year. Okay, entonces now, si es semi-annually, for example, it's 2 periods in 1 year, and the interest you earning half in the first period, and the first semi-annually, another in the second semi-annually, and together represent R. But the amount of period is not T in years. T always is the time in years. In years. However, so you have, for example, monthly, to say you multiply by 12, to say the amount of period is NT. Oh, and this is my famous formula. I want to use it for now. So let me copy the formulas. I want to introduce modification of this formula, and you need to be aware in the word problem, any situations of future value. So we have two possibilities. Well, we have two possibilities. Let me explain. Future value is equal present value, parentheses, 1 plus R over M raised to the MT. This will look like exponential. The money increasing exponentially with the time, the independent variable. Okay, this formula is the formula for the future value. Nice, future value. Suppose another problems in which I want to predict something. I want to compute the present value. So for example, I want to buy a car. To buy a car, I need $50,000. So 50K car. But how many money I need to deposit right now in the bank account with the interest rate R in order to get the $50,000 I need to buy the car? So I don't know. Maybe when you compute that, the answer is suppose hypothetical. I see in the word problem. Okay, we have $30,000. I deposit $30,000 now. In maybe 5 years, you have the famous $50,000 I need to buy the car. So another possibility is the formula not only for the future, the present value to do predictions. Suppose present value is equal, it's the same formula, but the only thing I did was isolate P. It's A divided by 1 plus R over M raised to the NT. Okay? But this is the typical discrete problem. Discrete problem. In the discrete problem, my money increasing like stairs. I suppose this is the time. This is my money. Future value. We start with the P, and suppose que es annually, semi-annually, monthly, I don't know. We have 1, 2, 3, 4. This represents the period. And my money increasing like that. Boom, 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 boom. Not necessarily the width of the test is the same. No, increasing more. Because the interest rate is addition with the. Okay, this is a typical discrete problem in which my money increasing like stairs. However, when you have no information of this and you want to predict, you simplify the thing using another idea. Que es, suppose que the money increasing continuous. Problem. And continuous problem means that the money increasing like that. Oh, look like exponential. Because the step is too small. Because you suppose in the continuous problem que M, que es the compounding, is a huge number. It's infinity. And when you apply, you know, when you apply the limit, this exponential is converting to the e. Remember the definition for the e to the RT. Now, don't forget the present value. This is a formula to estimate future value under the supposition que es compounding continuous. What means continuous is que the interval is too small and we have infinity interval. This is a formula for the future and the formula for the present. It's exactly the same, pero yo isolate P. Entonces, es future value multiplication by e to the minus RT. And the minus indicates reciprocal. Now, you can write like that, or you can write like that. Either way, divided by e to the RT. However, I don't know why I prefer write like that. Cool? Do you understand? Do you follow me? Do you follow me? Look like weird, complicated? Let's move into the word problem now. Do you understand the basic idea? Future value, present value, interest rate, time, compounding. Come on, guys. Say yes, no.
Yes.
Okay. No problem. You are ready to see the problems?
Yes.
Okay, cool. Let me try. Let's do in the first problem. I would like que you follow me using your own calculator. Okay, I set out the problem, I interpreted the problem, but you help me with the calculator. Boom. This is my first problem. Let me read, understand, you know, always is complicated word problem because you need to know that you read the problem careful. You need to know what is the information is given, and you need to know what is the information that they want que you compute that. Okay, if $10,000 is invested in an account at 3% APR, compounded quarterly, wow, how much money will be in the account in 5 years if no money is withdrawn? What information you see is available, is given? 10,000. What is 10,000? What is 10,000? What represents 10,000? What happened? No idea. It's P. It's a present value. It's the money that I have now. P. And let me change the color of this. P. P. It's 10,000. Cool. One more information is given. Invested in account 3% APR. What is the 3 APR? What is that in the formula? Let me copy the formula. The formula is interest rate. Okay. Interest rate is 3%. But immediately I convert to decimal. Divided by 100 is 0.03. You divide it by 100 is equivalent to moving decimal point to place it to the left. Okay, 0.03. And the formula never you put in percentage. You put in decimal, right? And what about compounding quarterly? What is the interpretation? Compound quarterly. What is that? What parameter indicate compounding quarterly? What value represent this? Compounding quarterly. The thing is que this account, n equal 4. This account is suppose schematically, suppose 1 year. This is the interval, 0, 1 years. And the account, this account, split the year in 4 parts. Okay? This is the first quarterly, quarterly 1, quarterly 2, and so on, quarterly 3, and quarterly 4. That means that our money, suppose that my money start in P, increase a little bit this, increase a little bit this, increase a little bit this, and increase a little bit this. This is the situation. So n equal 4. Cool. Understand very well. And they want to know how much money will be in the account in 5 years. So time is 5. Always the time is expressed in finance and years. And my formula is A is equal P 1 plus R over M raised to the MT. Okay, future value is equal to $10,000. 1 plus 0.03 divided by 4 and raised to the multiplication N and T together. And N is 4 and T is 5, so the exponent is 20. The exponent is 20. Okay, now, I want to, let me try to use in the virtual. Oh, no virtual. You try, and you let me know what is the answer. Come on, guys, put in your own calculator. So you don't know, I can train it to you, but it's important. If you don't know, let me know, because I open the virtual calculator and I show you the computation. Actually, it's exponential. So you put 10,000, open parentheses. So the display, what's the answer? Oh, okay, the answer, Angelo say que es 11,000, this is dollar, $611, and the decimal you run off 84 cents. Very, very well, 84 cents. Super cool. You are the best. Gladly. Excellent. Come on, guys, everyone, compute that. Today is the day of the calculator. No, show me. Suppose you have decimal, no? But we are talking about money, currency. Therefore, you truncate, or not truncate, run off to the near two decimal place, que represent cent. Jenny, okay, Jenny, no problem. Any question on this problem? Everyone understand very well? Or no? Yes. Okay. This is the first. It's easy, huh? Let's move on to the second problem. A little bit more complicated. Word problem number 2. Oh, it's a car. Okay, John wants to buy 30,000 dollar. He has 27,000. Find the number of year at it will take for his 27,000 to grow to 30,000 at 4% APR compounding quarterly. Okay. What is the information gets given? I need to understand the word problem. Just say copy here. Data. What is my data information of the word problem? Okay, what mean $30,000? What mean that $30,000? What mean $30,000? Is future. Very well. It's capital A. Capital A, que es the money I need in the future. Okay, nice. 30,000 is the money I need to have in the future to buy the car. This is 30. And what about 27? What mean 27? What mean 27? 27,000. It's a present. It's a present value. Cool. 27. Okay. I understand little by little. Now, what more information we have in the word problem? FP. It's the money I have right now. What more information we have? We have what mean 4% APR? And 4, how do you know get 4? Because it's quarterly. It's a language, a specific language finance. Quarterly means N equal 4. And the interest rate is 0.04. Okay, be careful, guys. In the practice, giving like a percentage APR, annual percent rate. However, no, in the formula you present decimal. Okay, entonces, what parámetro in the formula I need to know? Let me copy the formula. The formula says future value is equal present value. 1 plus R over M raised to the NT. What parameter I need to find? I need to find T. I need to find T. Okay, the amount of year I need to waiting by the car. Okay, super, I understand the whole problem now. The rest is algebra. 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 I recommend you no isolate literal equation. No. You plug it in, plug it in. A is 30,000. P is 10,000. 10,000, no P. No literal. The thing you know, you replace by numerical value. 10,000. Parenthesis 1 plus 0.04 divided by n, que es 4. Divided by n, que es 4. And raised to the n, que es 40. Okay, entonces in this moment, I can see clear that our equation is exponential equation. Because the unknown is in the exponent part, no? T, T, T. Okay, let me try to do my best. Okay, you divide maybe, well, you divide maybe 30,000 divided by 10,000. So basically, I move this division to the other side. It's all because 3, no? It's 3. Because cancel out 4, 0. 3 equal what? 3 equal 1 plus 0.01, que es the division. Let me make it zoom to see more clear. Division 0.04 divided by 4 is 0.01. And why no? Why no? 1 plus 0 is 1.01 raised to the 40. Wow, this is nice. This is my exponential equation problem. That is the reason that we study, guys. The exponential equation, the logarithmic equation, because frequently in the real life problems, not always, but the problem que talking about finance, some problem of the chemistry, biology. How come we using the 10,000? Angelus, how come? A ver, Angelo, I don't understand. How come? 10,000, 10,000, sorry. It's 27. I'm crazy. Thank you. This is 27. This is 27. So no 3. I don't know why I come from this. It's 27,000. Actually 30 over 27. This division is 30 over 27, que both numbers are divisible by 3. This is 10 over 9, no? 10 over 9. Oh yes, 10 over 9. This is not 3. This is 10 over 9. And this is 10 over 9. Cool? Now, how we solving this equation? Well, this equation is impossible solving in the traditional way, expressing the common base. No. Therefore, you need to apply logarithmic. What kind? Either standard, because we finish in the calculator. You apply ln 10 over 9 is equal ln 1.01 raised to the 40. And this moment you apply the property number 7 que allow us this exponent go to the front as a factor. You have logarithm of 10 over 9 is equal 40 multiplication logarithm of 1.01. We can use in ln or we can use in log, either way, the way you prefer. Now finally T is ln 10 over 9 divided by 4 times ln 1.0. And it's a t. But I don't understand anything. I don't know how many years. So I put in the calculator to determine how many years. John need to wait to is $27,000 growth to the $30,000. Come on, guys, calculator. Be careful with the calculator. Suppose that this is the display of the calculator. You put LM. I suppose you are familiar with this key. You press LM, automatically any calculator open the first parenthesis. You put 10 division 9, close the parenthesis, division, open parenthesis again. Why? Because we have two guys in the bottom. 4 times ln parenthesis again 1.01 and close to parentheses. The first parenthesis indicates finish the logarithmic in the bottom, and the last parenthesis indicates finish everything in the denominator. Now, this is the organization of the parentheses in the calculator. You do not respect the parentheses, the calculator understands another computation and give me wrong answer. Somebody get the answer or no? A ver, show me. 2.65, yeah, 2.65. Here's the answer. 2.65. Approximately, no? No, exactly. Approximately. It's irrational number. 2.65. 2.65 what? What mean that? 2.65 money, dollar? 2.65 dollar? What mean T? Years. Very well. Actually, this is an estimation, entonces almost 3 years. In 3 years, for sure, you'll have a little bit more money to buy the car. Jenny. But it's important for me. Remember, this is online class, and the person I checking one by one in your place. I show me your calculator. You get the answer. No, I don't know. Want to say explain, no? Okay, and in this case, you give me the answer. You get the same answer in your own calculator. Let me know, guys, please. Honestly, you say no. Yeah, it's playing the virtual calculator. All right. Yes, I got the same. Jenny. Everyone get the same? Do you understand very, very well the organization of the parentheses? Yes, I got the same. Jenny. Edward, yes. Come on. And what about the other guys? Okay, Angelo, Alejandro, my darling, Kyler, Kylie, Andres, Joshua. Okay, Camila. Camila, you did something or no? Camila, are you there? Camila is sleeping, definitely. This is the problem of the class online. I am here, okay. You are working in the calculator or you have no calculator? Remember, without calculator, you cannot pass this. Camila, I say, I am here. But here working or no? Camila, you have calculator, yes or no? Everyone, I know that you are here. My second question was, you have calculator or no? Everyone have calculator? Yes, I have. And your calculator allow you compute logarithmic or no? Yes, Clara said yes, yes. Come on, do it. You do it or no? Gladys. Okay. Do you want to explain in my virtual calculator or no? Not necessary. Yes or no? No? What do you think? Yes. What means yes, Camila? Please activate the microphone. Talk to me. Do you want to explain in the virtual calculator or no? No. Jenna dice no, pero Camila, what say Camila? Say again? Okay. Okay, let me try. Guys, you need to take one active attitude, no passive. If you want to learn, you need to work. Okay, there you go. Let me try my best. Okay. Camila, do you see my calculator now? Yes, okay, cool. Okay, let me put together in my, at least in my screen, the calculator and the whiteboard. You and your screen, you see only the calculator. But I need, so you put LM. Let me see the function here. Any calculator is different, no? You try to find the key in your own calculator, Camila, in which you put LM. LM what? LM 10 over 9. Now division. Outside division is this number in my keyboard. Is division, perfect. Parenthesis, open the parenthesis, important this parenthesis, because you ignore this parenthesis, you divide by 4 and after multiplication by no. Everything in the bottom is 4 times ln again of 1.01. And you see the answer. Press enter, bam, 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 and the answer is 2.6471. Depending on the approximation that you want, actually 2 years and a little bit more half of 1 year. Okay, 64.7, yeah, 64.7 is better. Years, 64.7. Let me copy my piece of paper, 64.7. It's not important. It's 2 years and almost 3 years. Camila, do you understand or no? Yes or no? I got it. Okay. This is the idea, Camila. Okay, let's come back to the whiteboard. Whiteboard. Okay, so we are doing 2 problems. The first was future value. The second was time. Switching to whiteboard. Do you see my whiteboard?
Yes.
Let's move on to the third problem. Third problem is a little bit weird. Okay, it's also finance, but in this case, find the future value. Ooh, future value. Find the future value that result from investing a present value 2,000 at 8% compounding continuously. Wow. For 1 year and 10 years. Okay. This word continuously indicate us that we change the formula because we have 2 kinds of formula. We have discrete problem in which the money increases like stairs. However, in this case, no. In this case, it's continuous. So the formula is future value is equal present value. E, pero this E is the Euler number, exponential, base E, RT. ¿Ok? And P es obvio que es 2000. And interest rate R es 0.08. And T is 1 years and 10 years. So the problem have to answer. Compute for 1 year and compute for 10 years. And M have no sense because it's infinity. We're not necessarily to talking about compounding because this word continuous clarify que es no stairs, es continuous, and we use in that formula. Okay, entonces now the future value at T1 years is 2000 que es P, exponential 0.08 times 1. And 8 in 10 years is 2000 again, exponential 0.08 times 10. One answer, two answers. Come on, put in a calculator. Using exponential, you need to be familiar with the exponential using E. Remember, any calculator have two keys. Any. The same key gets logarithmic. It's the organization of any calculator. I see here one calculator I have in my hand. You have LOG key. LOG is logarithmic. And LM is natural logarithmic. And the same key and the function second, we have the same but exponential, e to the x and 10 to the x. We are working with the e to the x. Now you put in the calculator 2000 multiplication. You select the function e, que es in my calculator second e, and you put inside 0.08 times 1. Times 1 is nothing, no? And just I get the answer. Come on, help me with the answer, guy. What is the answer for the first part? And what is the answer for the second part? Come on, everyone working with the calculator. Okay? Today is the day. Yes, you're right. It's 2,000. $166 and 57 cents. Let me know si I'm doing well or not. All right, show me. Also, Edward, good. Jenny, good. Okay, cool. Edward. Chelsea, Ross. What about the second answer? What about, then here is 4,000. $4,451 and 8 cents. Only 8 cents. Very, very well. Carajo. A ver, yeah. Chelsea, Ross. Good, we are the best. En Miami de College. Camila, you did or no? Camila, you did or no? My darling, I never see you answer. Yes. You get the same answer like me or no? Alejandro? Alejandro, yeah. Yeah or yes? Alejandro? Are you working or no, Alejandro? Alejandro? Camila dice, yeah. Alejandro no there, huh? You are sleeping, Alejandro. Kyler? Are you there? Wow. I understand why some students don't do well in the test. Okay, it's your responsibility, guys. Okay, let's move on to the next problem. Do you understand very well this? Was easy or no? Complicated or easy? Let me know. Because in the test, you see one problem of the finance, but in the test, you see two situations. And you need to compare what is the best option. And you compare both. There's a different formula, maybe, different parameter. And you estimate what is the best way. Let me try to explain one example, please. Okay, you have two problems in one problem, and you select the best option. Easy, okay, okay. I like that, it's easy. Suppose this. Let me try to understand. Compound interest formula again. We have a bond. A bond is a kind of investment you can buy. This bond is sell for the government or company. And after one determined number of years, you receive money, your money, and plus interest. It's another kind of investment. So the bond can be redeemed. This is the terminology que using in this. Redeem is que finish in 10 years. How much should be willing to pay it now? But well, okay. It's how much should be willing to pay it now if you want to return off. But I forgot something here in the problem. I return, for example, I need to get the return. Okay, the return is, let me write here. Fortunately, I have the board. 1,000. Okay, the situation is different. The situation is I analyze the price that I should pay now when I'm willing, no? It's a possibility to pay now if I want to return, so I receive in the future 1,000 or 10,000 or in the case 1,000 is given in the problem this. Okay, and so you have two possibilities, no? 7% compounding monthly. Okay, monthly, remember, is n equal 12. Or 6% compounding continuously. And continuous, remember, is infinity. You see, as infinity is different formula. Let me copy the formulas. Oh, no. Before I copy the formula, much better copy the information. What is 1,000? What is that? Present value or future value? It's A. Okay. In my problem, A is 1,000. And what about B? I have P or no? Present value? No? Yes? No? No, I don't have. It's exactly, I need to compute. But you compute two present value for the condition 1 and for the condition 2. And you make a decision, of course, what is the best option? In this case, the best option is the cheaper, right? Less expensive. Because I need to buy. Okay. So now we have two conditions, condition 1 and condition 2. And the condition 1, the interest rate is 0.07. And the compounding is 12. And the condition 2, the interest rate is 0.06 and the compounding is continuous. For continuous, the only thing que change is the formula. The formula for the present value, que is our unknown, is present value is equal future value divided by 1 plus R over M raised to the NT. This is the formula for the present value. And the formula for the present value in the continuous is e to the minus RT. Sorry, I forgot A. Get the future value. Okay. So let's do it. Plug it in and calculate. This is 1000 divided by 1 plus 0.07 divided by 12 and raised to the, well, how many years we have? I forgot that part. That part is important. T is given, 10 years. Then the formula, we have the multiplication n and t. N is 12 and t is 10. Entonces es 120 es the exponent. Okay, cool. This is the present value in the discrete problem, condition 1. Condition 2 is present value is equal 1000 exponential minus this exponent negative, que es recíproca, es the same, 0.06 multiplication by 10. Get the time 10 years. Okay, I set out the problem, I understand the problem. The rest is calculated. P in the condition 1 and P in the condition 2. And of course, I select the cheaper option, the less expensive option to buy the bond because I want to receive the same money in the future. Make sense? Do you understand this idea or super complicated? It's easy, eh? I understand. Okay, this is Chelsea. And the other student understand or no? Come on, this is the time to computation. Alejandro, definitely you are here or no? Alejandro. What is the answer, Camila? Camila said can understand. What is the answer? Oh, show me the answer. Show me the answer. Andres, are you there? Andres? Joshua? No answer. You have two possibilities to answer. Activate the microphone o at the chat. Entonces en the chat. Okay, I understand. Angelo, give me one solution. Angelo say, one solution is $497.60. A ver, show me. Yeah, Jenny. It's 400. So the price of the bond today is $497.60. It's a good business, no? Because you spend this money and you, well, no, not too much. Pero bueno, at least it's theoretical, you know? In the 10 years, whoosh, according to the inflation, it's not good business. But okay. And what is the price and the other possibility and it's continuous? Is, yeah, Edward, and the first is 497.60 cents. And the second? I give the answer is, sir. The same answer, no, I don't think so. No. So now you, and the condition 2 is, $548. $548.81. Cool. This is the answer. Condition 2, condition 1. Now this is a moment to make a decision. This is a moment. I am the previous matches. Okay. Okay, so now this is a moment to make a decision. What is the best option? What is the best choice? Option 1, condition 1, or condition 2? Condition one is the best option. Cool. This is bullshit. Nothing. Best option. Any question? Do you understand very well the finance problems? Cool. Chelsea said, yes, condition one is the best. Yeah, you're right. You're right, you're right, you're right. You're right. Okay, okay. Entonces, I promise que in the review package, we go over again to this kind of problem, the finance, no? But now I want to change to the problem of the biology or physics or physics or biology. It's basically physics biology problem. They involve exponential and logarithmic equation. Okay, cool. First one. The first one is about the exponential growth. For example, we can model growth exponential, growth population, growth population. Okay. And the formula, what is the formula? The formula is population at any time is equal to B null, que represent initial. This is represent initial population. E to the KT. This is very, very similar to continuous. Okay, we are doing in finance. This is the time, this axis time. Depending on the problem, this time maybe is in second, in minute, or in years, or in month, and this is the population. And we start at t equals 0. We have no negative part. This is today. T equals 0, you suppose. And we have P null, que P null represents the population. And this is exponential, and K, it give me the rate of change of this exponential. So it's like a velocity of this exponential. So actually, we have a family, wow, of different exponentials. However, in my problem, I have only one. And this is determined by K, is the rate of change. K is the rate of change. It's similar to the interest rate when you're talking about money, but this is not money. This is biology, you see. And now you find to any time the population of exponential. Okay, this is exponential growth. Exponential growth is when you have no limitation. So this is applied in the microorganism, like a virus, bacteria, and maybe some small animal, insect, maybe a rabbit, mice, in which is to be small because no limitation for the increasing. Okay, suppose that we have enough space and suppose that we have enough of food. It's not typical case of the, for example, human being. Never the population increasing exponential because the human being have contradiction. Okay, we have word. Okay, for the space and food. However, never the human being increasing exponential. This have no sense to talk about this. However, the microorganism, yes. Okay, this is the formula that we are using. Formula. Very, very similar to the formula that we are using in the finance when it's continuous. So suppose one problem. of this. Suppose the problem number 5. The problem number 5 talking about exponential growth, because talking about insect. A certain insect population growth according to the law of uninhibited growth. So no problema, enough space, enough of food. Initial amount of insect is, let me copy the formula. Identification, the parameter is given in the problem. Population at any time es equal to P null, que es the initial, y que es the exponential base, KT. So the information that's given in the problem is que we use that formula, okay, because it's law of uninhibited population growth. Two words indicate the same formula. Initial population is P null. P null in our problem is 500, no? 500. 500 what? 500 this kind of insect. And K is not given. No. And the time, I suppose K, yes, it's given. Okay, so now it's given, you know, hide it, the K, because give me condition 0. Okay, let me try to explain this. Pay attention, this look like at the beginning complicated, no? One image is one more, okay, 1,000 words. This image is the graph of the population. Population at any time, we respect the time. T equals 0 is today, right now. We have 500. This is 500. This time is 500. Look, 500. Let me use another color. 500 what? Insect. 500. And after this, increasing exponential. So this is condition 0. Let me call condition 0. Why condition 0? Because it's at t equals 0. However, experimental, I saw that at t equal 10 days, condition 1 is given, intermediate condition, is at t equal 10 days. That means that my problem, the time is in days. The population of the insect now is not 500, it's 611. So at t equal, suppose hypothetically, here, t equal 10. The population increasing a little bit, not too much, 611. 611 is the number of the insect at 10 days. This is called condition 1. And the condition 1 helped me to find the K value, because all information is given. It's given in the condition 1. The time is the population at 10, que is 611. So I can, this allow me find the K. And the K, remember we have a family of the hypothetical exponential, but we select only one. Okay, no problem. So now what is the final question? I don't understand anything. How many insects have in a month? A month is 1 month per 30 days. So to be compatible with the equation, the mathematical compatible, you need to express everything using the same unit of the time, que es day. So my goal is, this is 10, this is 20, this is 30. I need to investigate how many insects we have here. I suppose that this exponential continue increasing too fast. I need to find how many insects we have here. Okay, this is the axis of population. Continue. This is my goal. Come on. Do you understand the problem or no? And this, I call this condition 2. Condition 2. Do you understand the physics, the logic of the problem or no? I repeat something. Yes, you understand? Okay. So this is my equation. This is my equation. Here's the equation that I'm using, but I use it 2 times. I using in the condition 1 and in the condition 2. In the condition 1, everything is given, the time and the population. But the only thing that you don't know is K. Help me to find the K bar. And K is constant. Using the same K here and the same K here. But in this moment, we know the time, K 30, and I find P. It's doing. The formula is P to any time specific in this problem is 500. Because P null is 500. E to the KT. Suppose now that I apply the formula in the condition 1. C1. In the condition 1, population is 611. This guy is 611. Is equal to 500 e to the k multiplication by 10. Because t is 10 in the condition. The only unknown that we have in this is k. Okay? And solve for k. And you have k in my hand. Solve for k. Okay, this is 611 divided by 500 is equal to exponential 10k. I change here because I want the coefficients in the front. I feel more content. And you apply logarithm as typical exponential equation. But you apply logarithm, entonces the most convenient logarithm que you apply is ln. Because when you apply ln of this, it's obvious que ln of e undoes each other. So this is cancel out in my mind. Look at that. Cancel out in my mind. And we have only 10k. Therefore, k alone is equal ln 611 divided by 500 divided by 10. One possibility is you put in a calculator and you compute that. But what is the disadvantage of this? Okay. Cancel out e. And cancel out e. Angelo, you don't understand why I cancel out e? Angelo. What is your question, Angelo? Angelo. What is your question? You don't understand what is the reason I cancel out e? Yes or no? Angelo, come on. Activate the microphone. Guys, this is monosyllable. In the chat, I don't understand anything. Activate the microphone. Do you have available microphone or no?
Hello?
Hello, come on.
Yeah, I don't understand why you cancel out E.
Okay. The reason is, look, you apply logarithm on both sides in this moment. So far it's okay?
Yes.
So far it's okay. However, I remember very well the property number 3, que the property number 3 say logarithm base a arbitrary of the one exponential is equal x. Okay, and the reason is because, you know, exponential and logarithm are inverse function. And when you put each other together, o sea, it's like a composition, it's a technical name, undoes each other. Okay, in other words, I don't know if you remember, forget about property number 3. Another point of view. Logarithm and exponential together undoes each other. The logarithm e to the x is equal to x. This and this cancel out each other. Cool?
Yes.
Okay. Now, so far, we have natural logarithm of 611 divided by 500 equal 10k. And finally, solve for k divided by 10. Boom, and you get this answer. Focus, you guys. Now, you have two possibilities. You put in a calculator this weird thing, and you compute that. But what is the disadvantage of this? When you compute in a calculator, you lose digit because you round, you trunket. Now this error, this mistake, you introduce it with the second part. Remember, we have two parts in the problem. We have two conditions, condition 1 and condition 2. Entonces, one possibility is you leave it like that. You leave it like that. And continue working in this way. And you introduce in the final, the exact solution. Or another fantastic possibility is any calculator, any, have memory. You stores this answer in the memory, and we use it in the second part of the program. Either way. Suppose que I have no memory, it's hard que I have no memory, because elementary calculator have memory, but you don't know how using it. It's another possibility, no? Let's move on to condition 2. In the condition 2, we have the same situation. We have population in 30 days. The thing I try to find is 500, the initial population, exponential, and k is this number, is natural logarithm of 611 divided by 10 divided by 500, sorry, 500 divided by 10, and multiplication by t, que t is 30. Okay, no, it can simplification, why not? Look at that. This is P30 is equal to 500, exponential, es obvio que es logaritmo 611 over 500, and this is just 3, no? 3 here, because 30 divided by 10 is 3. And you put in the calculator this, and you determine the amount of inset that we have in a month. Let me know. And you trunk it, because we are talking about in biology inset. There's no decimal. Have no sense to talk about decimal of inset. It's a whole number. And you round down. And you round down. Come on, put it in your own calculator. This is a little bit complicated. Let me try to use my virtual calculator to support you. But no. You try, come on. You try. See, you don't get the answer to say I using my virtual calculator. All right, show me. It's the answer. Jenny, get the answer. The answer is 912. Inset. Get the answer. Who get this answer? Who get this answer? Gladys. Okay, Gladys. I know. Who more? Edward. The rest, do you know que I want to show you in my virtual calculator or no? Camila. Rachel. Wow. Monday. Do you want to show you how we put in the calculator or no? Sure. But let me know. Okay, let me try. I want to share calculator. Do you see my calculator, Camila? Oh no. No?
Yes, I see it.
Okay. Okay. Entonces, en my calculator, I put 500, que es the initial, 500. Multiplication. And you put exponential. Exponential is this function. I don't know exactly in your calculator, Camila. Exponential, so you put an exponent, you put 3 times, and you put, oh, no good. No good. You put an exponent, 3 logarithmic natural, of course, of division is 611 divided by 500. Bam! Yeah, I get the answer. Look at that. The answer is 912. And you negligible, ignore the decimal because have no sense according to the problem. No? It's inset. Inset is a whole number. 1 inset, 2 inset, 3 inset, no decimal, have no sense. Cool, Camila? You try, but the important is that you are doing your own calculator. It's important for me. Okay, Natalie, you did that? Natalie Nunez.
Professor, may I ask you a question after we're done with this exam?
Go ahead.
On the last question that we were working on, I just wanted to see you put it in the calculator because like on mine, I kept getting error even though there was an answer. And I just wanted to see how you would do it. I'll write it in the chat.
Okay, what question you talk about, this or the previous?
No, the previous one.
Oh, and what was the problem? Error.
I'm gonna write it in the chat, the exact equation. Like there was an answer, but I just didn't know how to put it into my calculator to not get the error.
Well, I don't know. You see, you put in the chat something. Let me see. In the chat, you send me something. What your name is?
Jenny, I'm typing it up right now. Sorry.
Right now. Wow, I understand. Maybe, Jenny, the problem is okay, you need to enclose in the parentheses. Do you want me to do it for you in the visual calculator?
Yes, please.
I understand the idea. Okay, no problem. I understand. So you put 1,000. Yeah, 1,000. Okay. Do you see my calculator or no?
Yes.
Yeah. 1,000. Just the present value. You put the multiplication, or I don't know, depending on the calculator. And you put exponential, like that. But this, not e, sino e to the x. Maybe this is a mistake. Some calculators have both, but e to the x because allow. Put the exponent. You're supposed to put both, but it's more complicated. So you put minus. I understand where's your problem. Your problem is that any calculator, we have two negatives. The negative of the subtraction and the negative of the negative value. Entonces, for example, in the calculator I have in my hand now, I have one negative in white color, que is the negative value, and I have another negative in the gray color, que is subtraction. And so you put subtraction, of course you get the mistake, right? This is minus 0.06 times, boom. A ver, no, mistake. This time is in the top part, here. Multiplication. Pero no down, coño. A ver, let me see, here. Bueno, actually, let's do it by hand. Es 0.06 times 10 is equivalent to say 0.6. I delete 1 0. Bang! And this is the answer, Jenny. $500, 548. and 81 cents. Cool?
Thank you. I got it. I had done the.
Your mistake was, remember, in any calculator, you have two negative. One negative subtraction. And to be subtraction, we need two elements. This minus this. However, when there's minus alone, it's because it's negative value. Okay? Cool. Okay. Let's move on to another problem. Do you see my whiteboard? No, I suppose que no, no? No. Let me close the chat. Here, whiteboard. Switching to whiteboard. Okay. 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 Do you see my whiteboard now? Oh no.
Yes.
Okay. What is that? This is the problem number 6. Problem number 6. Okay, let me explain in detail problem number 6. Typical. I can see it. Okay, Chelsea. Look, guys, this is the archaeology frequently using the carbon-14 test to find the approximately the age of the antique thing. Okay, the archaeologist take the sample under the ground, go to the laboratory, and the laboratory apply carbon-14 test in one device. And carbon-14 test analyze how many carbon-14 stay inside the sample. Carbon-14 is the best popular element, chemical element in the nature, because everything is carbohydrate, wood, cartoon, paper. It's a carbon-14. No metal is different, but at least one part is organic. And then what's the idea? The idea is clear. Look, they know very well. This picture illustrates a little bit, but not clear. Suppose a lot of years ago, here, t equals 0. It's a lot of years ago. We have 100% carbon. And a piece of wood or piece of something. This is amount of substance to any time. And to the time decreasing. The physics know the half-life. Look, this is the most important parameter. Half-life of the carbon-14 is 5,600 years. Wow. What means that? Means that 50%, that is the reason that half-life. Here, the time the carbon-14 decay is 5,600 years. It's a reference. Okay, this is called half-life. Half-life of any radioactive isotope. Half-life. Maybe plutonium, maybe uranium. Carbon-14 is not too much intensive isotope, radioactive isotope, is radioactive isotope. And during the time they disintegrate or decay. Okay, entonces our problem is determine so you have the formula is very, very similar. Is amount of substance, in this case carbon-14, at any time is equal initial amount, A null, E to the KT. But do you say, well, professor, it's the same formula? No, it's not the same formula, because in this case K is negative. Si K is negative, that indicates us that the exponential is decay, it's going down. So it's no growth population, it's decay exponential. Do you understand this? At the beginning, you don't know. At the beginning, you don't know, okay, it's decay. But in the algebra, when you solve the algebra, indicate also. Okay, yes. Is again, in this case, we have condition 0, because at t equals 0, condition 1, and condition 2, because the thing is, I need to find, it's a little bit different, a trace of burned wood along the ancient stone tools were found to certain approximately 1.67% of the original amount of carbon-14. O sea, the percent is too small, is 1.67%. Okay, bam, 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 bam. I want to determine the time que corresponde with this condition. This is the time axis. Okay, we continue. Suppose here, I need to find this time. Do you understand the idea? Or it's complicated? And this is called condition 2. So this problem is complicated, guys, because we have 3 conditions. Condition 0, condition 1, and condition 2. Condition 0 always give me the amount of substance. Can you suppose in this case 100%? You have pure carbon-14. It's a 100. Of course, percentage. Because everything is expressed in percentage. Okay. Okay, this is condition 1, condition 0, sorry. Allow me find the A null. And condition 1 is using to find the K. Find K. And condition 2 is the last condition to find the thing that you want to know, que es the time. Do you understand the logic of the problem or no? Do you understand the logic of the problem or no? Yes, Jenny, I understand the logic of the problem. Okay. So now, okay, we write condition 1. On condition 0, I did that. I replace A null in this specific example. I get it, okay, Chelsea. Condition 1, Chelsea, is 50%. In condition 1, we have a half of the carbon-14 isotope, 100, e to the K, and the time is 5,600 years. Wow. And the only unknown I have in my problem is K. You divide by 100, both sides, 50 divided by 100. It's obvious it's 1/2. It's logical because it's a half-life. Equal e to the K times 5,600. You apply logarithm of both sides because you have logarithmic equation, ln of 1/2 is equal, and ln of e cancel out the ln and e by the reason I explained before, and we have 5,600K. Therefore, K alone is logarithm of 1/2 divided by 5,600. Everyone follow me so far?
Yes.
Yes.
But I realize that this K is negative because logarithm of the number less than 1, because it's 1/2, is negative. So if you put in a calculator, I guarantee 100%. You put in a calculator, logarithm 1/2 divided by 5,600 is negative something. And that means it's decay, decreasing. Okay, one possibility, I repeat again, guys. You put this in the calculator, so you understand very well how you manipulate the memory in your own calculator. It's super easy. You store this information inside the calculator, and you continue for the second stage of the problem, and you compute this, but you replace K for the value of this. So you have no memory, or you don't know how we're working with the memory. We continue with the second part of the problem, condition 2. In the condition 2, we're using the same formula, that formula, but I know que amount of substance is in the condition to 1.67% is equal 100 e to the k. Who is k? This is k. And multiplication by t, que I have no idea. I have no idea. Now algebra. You divide both sides by 100. 1.67 divided by 100 is equal e to the kt. And you apply now natural logarithm again. Now you take advantage that natural logarithm and exponential with the same base undo each other. So you have logarithm of 1.67 divided by 100 is equal to kt. But I solve for t. T is equal natural logarithm of 1.67 divided by 100 divided by k. And who is k? K is natural logarithm of 1/2 divided by 5600. You replace this for this. Okay. Okay, entonces, come on, put in your calculator. And the answer, k is negative, however, the answer is positive. Because actually we have two logarithms, and the number inside the logarithm is less than 1. So negative divided by negative is positive. And t is positive. Actually, if you want, you put in a calculator in the best way. Look, put in a calculator like that. Natural logarithm 1.67 divided by 100. You multiply by 5600. You put this in the top, and logarithm of 1/2. Something like that. It's better, right? Come on, doing. Try. So you cannot, I do in my virtual calculator. Exactly. That's the answer. The answer is 33, Angelo. It says 33. Okay. Let me see in the chat. Answer, Angelo. 08. Let me try in my virtual calculator. You are close. Well, at least the answer I have in my piece of paper, no? But I did sometime before. Okay, 33062. This is the answer. The answer is approximately you know, 33,062 years. And that's it. The decimal is totally irrelevant in this scenario because it's 33,000 years. I didn't put 7 and 1 point. Oh, okay, I understand. Okay. Do you want to do in my calculator, Camila? Oh. Where is Camila? Camila. Do you want to put in my virtual calculator, Camila? Or you did? Yes, please. Camila. Pero Camila, you have calculator or no? Answer me. You have calculator or no? No, it's okay. Si es no. It's different. Could you show me your calculator? You can activate your camera and show me your calculator. What is the model of your calculator? For example, this is, I have a lot of, no. Okay, I have this calculator. And this calculator is fantastic because you have logarithm here. Let me show you logarithm here. Camila, look. This is the key. logarithmic, this one, and natural logarithm. This is one kind of calculator. This is elementary, cheaper. You have sophisticated calculator. Well, it's okay. It's a sophisticated, no. But no, not necessarily sophisticated, no expensive, cheaper calculator. You know, for example, Camila, look. Oh no, sorry. Whiteboard. Do you see my whiteboard, right?
Yes.
Let me try to
Yes,
show.
I see.
Let me try to show you one typical picture of the calculator. Get over there. Do you see this calculator? Do you see? It's very similar to
Yes.
the calculator you have. It's very similar to the calculator you have.
Yes, that's how mine is.
This is exactly it you have.
Yeah.
But it's fantastic. Let me show you how.
Okay.
Let me show you. You're using this key. That key. ln, right? And you put ln. Show you. Suppose it's a chain. Okay, this is just a picture. But you suppose this is your display. And the thing I want to compute is this. Wow, too long. You copy. Let me make it zoom. You copy. You press this key. When you press this key, you see ln alone. Yes or no? Automatically, this open the first parenthesis. You follow me? Everyone follow me? It's important for me you follow me because you need to do by yourself in the test. Now you put here inside. Suppose that this is this logarithm. You put 1.67 divided by 100. And close the parenthesis to indicate that we finish the logarithmic part. Now multiplication, period, multiplication, this key, multiplication 5600 divided by division is this key. Okay, and to send this case, not necessarily parenthesis, because it's only one expression at the bottom. Si es 2, yes, pero si es 1, no. You put ln 1/2 and close the parenthesis and press enter. And let me know si you get the answer or no. Press equal, enter. It's important for me that you are willing or you are aware how we put in the calculator. You have calculator, but you don't know how manipulate the equation to say you never get the answer. Okay? Tell me something. You did or you don't? Come on, the students, que follow me. Camila, you're doing it. Gladys, go, okay, I got it. Super Gladys. And Camila, no? I got it, this is Jenny. Okay, cool. Nothing, Camila. Camila, say something. I don't want to pressure. Wait, I'm waiting. Okay, cool. Okay, super. Entonces, in the time that we have, we're doing one more problem. And that's it. Okay. Do you see now my whiteboard or no?
Yes.
Okay. Okay, one more, and we continue next time. No. Oh. Okay. Okay, this one. This one is different. Don't worry too much for the formulas. Because I want to, when you finish that, I summarize the formulas. And you don't need to memorize. Because actually you copy in one piece of paper. You classify the kind of problem. No? The final problem, future value, present value, growth population, exponential decay. And also now cooling, Newton law cooling. So what is the idea behind Newton cooling? Suppose we have an object. Suppose we have an object. I don't know, pizza, cake, I don't know. One object is very, very hot. Using one initial temperature, it's big temperature. After we read that, and you determine what is the temperature. But when you relieve this hot in the one room, of course, this room have air conditioning. We have one temperature final because the heat is transferred outside the object and the temperature decreasing. Like that. This is the time, the temperature to any time. We have initial at t equals 0, t initial, and the temperature decreasing, but not decreasing to 0, decreasing to the one value que is called final temperature. Okay, and what is the formula? The formula is temperature to any time is equal to temperature final plus temperature initial minus temperature final e to the kt. It's the formula for the Newton cooling. Entonces, likewise, two temperatures given. The K is not given, but to find the K, we need some condition. Condition 1. Condition 0 is initial. Condition 0. But you have one intermediate temperature here. Condition 1. Intermediate, let me call T1 and specific time 1. See, this information is given, allow us to find the K value. Find the K. Okay, and when you find the K, we continue for the condition 2. Okay, the condition 2, maybe you have the temperature. I want to find how long we need 30 degrees or no, or what is the temperature at T equal 100 minutes. Depending, no? Depending. Some problem is given the time and you need to find the temperature, or some problem no. Some problem is I have the temperature you want and you need to find the time to occur this temperature. And this is the formula. Let's come back, at least to read the problem. No, not solving today. Read the problem, and I want to. An object is heated at 100 Celsius degree. So temperature initial is 100 Celsius degree. And then allow to cool in the room whose air temperature is 30. So temperature final, so you, for example, you leave the object in the room and you come back tomorrow. Well, I suppose all heat is go outside the object, and the temperature of the object is the temperature of the room. This is the final. All right, now complementary information. Celsius degree. If the temperature of the room object is 80, so it's given one temperature I want to call T1 is 80. Of course, intermediate value and between 130 at at 5 minutes, t equals 5 minutes. This is the condition one que help me to find the k value. When, entonces the question is when is temperature at 50? So I want to find when is time, how long. So I have T2 is 50. Yeah, I want to find at what time is. Do you understand the problem? Do you understand the problem? Do you understand the problem? Yes or no?
Yes.
Okay, so let's do it here, no more, because today I'm doing too much. We continue. So basically, you have 2 more problems, and we start review next time. Okay, next week. Okay, guys, have a nice days. Enjoy your days.
Yes, sir.
Professor.
Bye-bye.